know some of the people in here actually, but what's really creepy is that I run into people at LinkedIn at like Hadoop summits in different places, and for some reason they know me and my name. I don't know, I come up in your algorithms, and it's just a real creep factor. I gotta let you know that's the way you guys work, but I guess that's a good thing going for you. So yeah, my sort of couple sentence background. I worked in batch and distributed computing for almost it's been almost 9 or 10 years now. I started in the research-related facilities doing actually computational genomics for the Department of Energy. And it's very different, but very similar underlying architectures. And then, I don't know, 6, 7 years ago, I moved into the internet industry, and really been enjoying it since. And as you said, presently I work on Facebook, or at Facebook on HDFS, also related to Scribe and other data acquisition and flow systems. So that's basically me. What I want to talk about today is what we call our data freeway at Facebook. I'm going to focus on the data acquisition and flow portions at Facebook. I understand there might be some questions about the warehouse side of things, Hive and what have you, and I'll answer questions as best I can about that. I'll also, per request, talk about a couple of add-ons that we have for Hadoop. There'll be contrib projects in the open source. This is the RAID node, which basically allows us to reduce the storage and also decrease the chance of data loss, which we'll talk about a little bit later. And also the avatar node, which provides high availability for the name node. In that sense, it's also a hot standby I wanted to add. And something I forgot to ask up front, are we taking any questions during the presentation, or are they all at the end? I was going to say, I don't mind questions in the middle. I think it's easier to understand what's going on if you ask when you have the question than holding it till the end. So it's up to whomever, when you have your question, just ask or save it. So for the data freeway at Facebook, in order to make this thing useful, we had to provide measurable guarantees on both data loss, reliability in other words, and the latency. For us, we measured latency as the time it took from a web client to generate a message to the time that message showed up on HDFS and was readable by a client. So nothing on the inside. It had to be what our users would see. And we typically see what the TP99 of 15 seconds means is it's 15 seconds or less for 99% of the data to show up 99% of the time. That's just our sort of little shorthand there. And we typically see this at 10 seconds or less for higher volume categories. Smaller volume categories, it actually can exceed this. We're still working with some HDFS issues on that. The reliability, we measure this in a similar way. We want to do it from both client to client, the client that logs it and the client that reads it. What we do here is we sample a small amount of the data and we insert it into a MySQL database or set of databases. And then when the data flows through the whole system all the way to Hive, we actually run some Hive queries and calculate the data loss that way. Here, our goal again is 0.02%, and we actually come in under 0.01%. So it's pretty good, especially even given the volume of data, which I'll talk about a little bit later. And it's because of these different things that we've actually been able to get customers with these wide variety of real-time use cases. And lastly, what the data freeway does is provide a standard uniform pipeline for data to get from web clients to the warehouse. And this is just a kind of a high level, super readable, I guess. It's sort of a simplified diagram of what happens for the data freeway. So when I was referring to clients in the previous slide, in this case, this is 99% of the time web nodes in what we call our web tier. I'll talk a little bit more about all these pieces in detail, of course. And web clients here are an HPHP instance, which is Facebook's compiled PHP server. It's a library we call Nectar, which is a PHP and sort of JavaScript library for logging events. And then Scribe, which most people know is a logging or a message passing system. And these systems are co-located, they're located near a dedicated Scribe H cluster. So we back up, there's clusters of web machines, and they have a dedicated Scribe HDFS cluster. So there's a fat pipe for the data to get to Scribe HDFS. We then have what we call the copier process that will copy the data from Scribe HDFS to our centralized warehouse HDFS. And also, in order to provide the lower latencies, the lower latency is guaranteed to the p-tail instances that you can see here, the little boxes on the top and the bottom. Those are client-side, so that can be anyone. It's on a dedicated server or a service. And like I said, those things get the lower latency data. The latencies we provide to the warehouse HDFS right now are a little bit higher. It's anywhere from 15 minutes to an hour to be queryable by Hive. So now, like I said, I'll probably run through a little bit of what I've just said, but we've got Nectar. Let me back up here, sorry. So everything starts at the client libraries. Nectar is for anything that wants to log in PHP or effectively JavaScript by embedding JavaScript in web pages that users browse. Any other clients go directly to Scribe, which is also fairly easy because Scribe supports a Thrift interface. And those of you familiar with Thrift, you know that you can compile Thrift into almost any language, I think even Perl, for example, and get data in just fine. One of the major benefits of using Nectar for people within Facebook is that it inserts a standard set of attributes. So you can imagine, I don't know, user's browser type, possibly screen resolution, some server-side attributes, maybe that they pull in like their IP address of the request. All of this is just standard so that if I'm a developer, I insert some code in my PHP inside the main Facebook code base for the front end, and voila, I've got an event logged, and it also shows up all the way through the pipeline in Hive, queryable, in a table based on the category name that I give it. And then another comment about Scribe that I wanted to make is it's resulted in a massive proliferation of applications being data-driven at Facebook. And as you can possibly guess from Nectar, Nectar has just made this, it's really just multiplied the effect and made it even easier. Let's see. Regarding Scribe HDFS, one thing I want to add here that's not on the slide is that we co-locate the Scribe daemons with HDFS. So you can think about that as an HDFS cluster, where each data node also has a Scribe daemon on it. PTEL, like I said, I've already talked about that. It basically provides streaming access to the data. And what it does is it simplifies it. So you can imagine that data is being logged across many machines, across many Scribe HDFS clusters. Users don't want to have to deal with or know anything about this. So they just say, you know, I logged category foo. I can get a stream of foo's data. And that's what PTEL is going to give us there. It's also the tool, incidentally, because our clients use it. It's what we use to measure our latency. So the next piece in the data freeway pipeline is the copier. The copier is an interesting beast for us. Our current copier is basically a system of cron jobs that wake up periodically. They do an LS on the source and destination system and then use MapReduce jobs to do a distributed copy. We actually also have a legacy copier system that copies from NFS, and this is a holdover from when Scribe wrote most of its data NFS. We had to have a dedicated cluster to copy that data into the warehouse HDFS. Now it's similar in spirit, but it's a copier job that runs on the Scribe HDFS clusters and then moves it into the main HDFS. And then this is sort of a three-tiered system here. There's now a new copier that's in alpha or beta testing, depending how you label it, that we call the continuous copier. And I think the take-home from that is that it's centrally managed. We'll talk more about this, but it's centrally managed, and it reduces the latency by getting rid of all the LSs that the previous one did. And the next piece in the pipeline is the loader. The loader, as you can think about it, is once the copier finishes, the data is on the warehouse HDFS cluster, as the diagram showed, and there's a small process that creates partitions in Hive and makes it available for query. I'll go over some distinctions between that. There's a distinction between data that's available today for the current day and data after the close of books, which is data for the previous day. One note about the warehouse cluster mentioned here, that's our biggest single cluster at 2,500 nodes and 25 petabytes. There's probably another 500 or 1,000 nodes coming in that, and we tend to bring those in very small phases constantly. In other words, if we waited to order all these until at once, we would absolutely run out of space. We're always running in the red on space and also memory. One other thing I didn't put up here, our name node runs a 58 gig heap, and again, that's constantly running out. We have to clean up files on a weekly basis. So provisioning machines, especially for space, is critical for us in the scalability world. And so it's going to, I guess I can sum up Nectar again in a couple more details. It's basically versatile and it's easy to plug into any part of Facebook's code base to get that count. One thing I didn't mention is that you can actually add more attributes to the standard ones very easily, and they basically just show up as columns and values in your Hive table. So it really couldn't be much easier. It also integrates with the real-time monitoring system. It's not unlike Xenos, actually. It's an in-house thing that Facebook has, but it's the same sort of thing. You send data periodically, it aggregates it, and you can do averages, sums, medians. And this Nectar will do the sampling for you and sort of fork the data for you at the client. So moving on to the next piece in detail here, we've got Scribe HDFS. So we organize Scribe itself into tiers at Facebook. Basically, we have a two-tier model right now. In this model, the web tier can talk to anything in the Scribe HDFS tier. They're totally symmetric. This basically means that for load balancing, a web tier machine will get a list of the nearby with respect to network Scribe H machines, and just pick one and be sticky. It'll stick to it until there's an error. So the load balancing isn't perfect, but we find that because all the web tier machines in a given cluster are talking to the same Scribe H cluster, that the disk space per cluster evens out, and there's a little bit of variation on network traffic, but it's within acceptable limits. We're planning to move to a three-tier model, and we'd like to use Zookeeper for this, and I'll talk a little bit more about this in a slide about Scribe. But basically, the only other bit we have network topology-wise is we actually have 7 Scribe H clusters right now. It's not exactly a one-to-one map to our web clusters. And let's see, this is the type of hardware that we use. Hadoop is, of course, designed for commodity hardware, so that's actually pretty much what we do. One thing you might notice, there's a fair amount of CPUs on these boxes. You might be able to get more, I'm not exactly sure, but 16 threads seems like a fair amount for an I/O-bound system here. We make use of this by doing compression because we found that network bandwidth is actually the scarcest resource in our system. The other thing to note here, we pack disks in pretty dense. This is denser than what I'd seen previously with 12 disks and 12 terabytes per node. An interesting consequence of this is that it greatly increases the probability that an individual machine will fail. Right now, the way the data node code works in HDFS is if any single disk goes bad, the whole node can at least end up in a very sick state and be unresponsive. We've seen I/O errors, indefinitely hang threads. So we're actually looking into making that per volume. For anyone familiar with HDFS, the volume is per path that you set up, and for us, that's one of the 12 disks. Sorry? I'm in trunk right now? Okay, that's good because the person we just hired from Yahoo, Hairong, didn't seem to know about that. So well, I'll go back and ask her. Maybe I misasked the question, but thank you. That's good to know. So anyway, we would like to change that over. We're currently operating on Hadoop 20, actually. I should have mentioned that. So we might have to backport that. Let's see. So we've actually, regarding the disks failing, we've actually seen a fairly high incident of this. It's within the past 3 or 4 months that we upgraded to Hadoop 20 to our internal branch. And it's maybe like 1 a week or something that's going into repair, and we'd like to be able to handle that better. Like I said, as far as running HDFS, it's an internal revision based on Hadoop 20. It's got a lot of fixes to it. I'll talk a little bit more about the details in there. One of the things that I'm not fond of here, though, is using Scribe itself with HDFS requires having to use JNI, which can be a little bit clunky because it's a C API. We actually found a couple of small memory leaks. I've even added some myself and then removed them when I found them. The last piece of software here is the MapReduce, which is used to run the copiers that I was talking about earlier. And moving on to Scribe. All right, so I think I would say Scribe, probably ascertained this already, but Scribe is the source or front end to our data pipeline. It's been widely adopted in Facebook because it has a simple API, and as far as the operations side, it can be laid out in a multitude of ways, and it's useful well beyond its original intended purpose of a logging service. However, as you can see here, and I've talked about in the data freeway use cases, it transports free messages, and I would actually describe it as a de facto message bus at Facebook. It was just there, and it's what got used. And so for applications that need to log data from the front end and move it to a back end to make decisions or what have you, this is what Scribe is used for. All that said, it's far from perfect. Configuration management is actually really difficult in the sense that you've got a large number of machines that need to have synchronized configurations. If you want to try to introduce the middle tier that I was talking about for routing earlier, that's currently a static configuration file. So if you